There's a study from the 70s that claims the way you talk to food can affect how moldy it gets. I am not making this up. In the study, the researcher put rice into jars, and then for several weeks he talked to the rice. Some of the rice he was super nice to, and some of the rice he insulted every single day. He claimed that the rice that got insulted every single day got moldy faster than the rice that, only had positive, nice, loving comments. And TikTok has really run away with this. So let's take a look and see if there really is a relationship between how you talk to your rice and whether or not it gets moldy. Okay, so I've got some data here. I'm not gonna lie, I didn't actually watch 100 TikToks to gather all this data, okay? I made up the numbers. Please forgive me. Feel free to waste your own time watching these videos on TikTok. Okay, so the first thing we're supposed to do is find the marginal distribution of the mold growth. So marginal means we look all the way to either the right or the bottom. Since we want to focus on mold, not on kind versus mean, we're going to ignore the middle parts and we're just going to look at this margin. So this is basically like overall how many jars got moldy and how many jars had no mold. So overall, we've got 49 out of 74 that had mold, and we have 25 out of 74 that did not have mold. So that's 66% and 34%. So we can see that the majority of jars did produce some mold. Now we're supposed to find the conditional distribution by the type of words being spoken. So of kindness and of meanness. So let's start with of kindness. We're focusing on this column. Of the jars that experienced kind words, 22 out of 34 had mold, and 12 out of 34 had no mold. So that's 65% and 35%. Now, of the mean jars, 27 out of 40 had mold, and 13 out of 40 had no mold. Okay, so that's 68, and we'll call it 32. There's a bit of a rounding error there, but similar trends with the kindness and the meanness. So now we're going to graph. Let's have 1 bar for kindness, 1 bar for meanness. Let's make super straight lines. Honestly, some of my best work. Let's go. Okay, so for kindness, 65% had mold. And for meanness, 68% had mold. Those are going to look pretty similar. Let's make a key. This is mold. This is no mold. Yep, those look the same. So follow-up question. If you know that a jar of rice was treated with kind words, does it make it more or less likely to have mold? If we look at this graph, the answer is clearly no. Whether the jar experienced kindness or meanness, it was about 65 to 68% chance of there being mold in the jar. So who could have seen this coming? It doesn't matter how you talk to your rice. You leave it out on the counter, it's going to get moldy. So the answer is no. Knowing that the jar was treated with kind words does not make it more or less likely to have mold. It's the same probability, whether it was treated with kindness or meanness. What that means is our two variables are independent of each other. The way that you talk to your rice is independent of how much mold is in the rice. Independent meaning they have nothing to do with each other. Now, in everyday life, when we say independent, we often mean like alone or like by yourself. In statistics, independent means like they don't interact with each other or they don't influence each other. So like if you were taking an independent study, you're taking a class on your own, you're not interacting with the teacher. You're on your own. Kind of the same thing. So now let's think about what would it look like if two events were not independent. We can actually use the example from our previous video when we were comparing age versus the type of delivery device for your gelato. In this scenario, knowing that a customer is a kid increases the chance that they get a cone. And here's how you can think through it. Let's say I ask you, the next customer that walks in, I want you to guess if they get a cup or a cone. If I tell you that that customer is a kid, you're probably going to change your guess to cone. Because based on this graph, kids are more likely to get cones than adults. But in this scenario, if I say, okay, I want you to guess if the next jar has mold or not, and I say, by the way, it was spoken to with kindness, it's not going to change your guess because the kindness and the meanness bars look almost identical. When two events are not independent, you would think that we would call that dependent. We actually call it associated. Okay, I didn't make the rules. No one asked me what the vocabulary should be for statistics. I'm right here if anybody wants to ask, but no one's asked. Two events being independent means they don't influence each other at all. If they're not independent, they are associated. It means they have something to do with each other. Your age might be influencing if you get a cup or a cone, or something to that effect. So your options are independent or associated. I feel like I've managed to talk about gelato for like 5 videos in a row. How is that possible?